How far can mirrors reflect? When you put two mirrors in front of each other, they create a seemingly infinite tunnel of mirrors. But it slowly fades away, as it keeps perpetually reflecting off of one another. Is there an estimate distance as to how far this can go? The degree of reflectivity of materials is well known. A household mirror, with a glass front and aluminium back, is around 80 to 90% reflective. This means around 10 to 20% of the light energy is absorbed instead of reflected every time light bounces through it. But because of how math works, it never truly becomes zero light. We just think the image is too dim when it gets into the few percent range, which would expect from around 10 to 30 reflections. When you are looking at one mirror from another mirror, one of the things you will notice is that much like as you look at things further away than something up closer, it appears smaller. So each reflection is gradually smaller and smaller. The amount of which it is smaller depends on the distance between the two mirrors. At some point though, it will make one of the mirrors too small to see a reflection from that mirror. Just like if you go to somewhere where you can see a long distance, perfectly flat land, on a hilltop, a mountain top of a tall building, etc., you will reach a distance that things are just too small to make out what they are. If you have two perfect mirrors in a perfect vacuum, you will have an infinite number of reflections between two mirrors in such a setup. However, the world doesn't really work like that. Most mirrors you see will have a pane of glass between the mirror surface and the air. It essentially makes each reflection look like it is going through multiple panes of glass. The glass will both reflect a scatter light. On these sorts of mirrors you will probably be able to see anywhere from 100 to 500 is reflections until things get too dark. But there are mirrors called first surface mirrors that reflect most light since there isn't any glass in between the mirror surface and the air. On these theoretically you could probably see many thousands of reflections, but the limiting factor here will be how much light scatters in air. Then let's float one more idea. What if you put these first surface mirrors into a vacuum, with a camera and a laser? How many times could the laser be reflected? It could be reflected probably millions of times depending on how shallow of an angle you can shine the laser into that setup. Here is a bit of trivia for you. We can call this setup an optical cavity. Eventually the mirror will absorb all the light from the laser, or the laser will bounce outside of the setup. But this will take considerably longer than it would in the more regular setups we were talking about. Mirrors just cause light to bounce off of them. If a beam of light enters the gap between two mirrors at an 89-degree, near perpendicular angle, it will only be able to escape after bouncing between the mirrors dozens or hundreds of times before it is able to reach your eyes. However, all that bouncing essentially makes the original beam look like it came from very far away. The limit is less about what the mirrors can handle, and more the fact that humans can't see details hundreds of feet in the distance. The mirror really has nothing to do with distance. It has to do with intensity. Once the light bounces off the mirror, it's not tracked how far it goes. It works just like any other light after that. What reflecting off a mirror does do is reduce the amount of light. The image you see of yourself in your mirror is only about 80% as bright as the image someone would see of you with their own eyes looking right at you. It's a bit dimmed, but still plenty bright enough to see it.so. When you have light bouncing back and forth between two mirrors, the distance between the mirrors isn't really the point, and the distance the light travels isn't really the point. It's simply the number of times it bounced. Each time it bounced, it got slightly dimmer. Eventually, after enough bounces, it's dim enough to not be noticeable anymore. And where did the lost energy from that light go? It got absorbed into the mirrors. Just like what happens every time light bounces off a normal black-colored object where most of the light doesn't reflect. Except in this case it took more bounces to eventually lose that energy, since it only lost a little bit each time.
Don't forget to like and subscribe so you don't miss our next exciting video.